Hello, welcome to this very high-level introduction of ATS Inspect. We will only focus on the core functionality of entering a defect, answering checklist questions and repairing the defects that were found. We are looking at the operator interface, data collect. The operator interface is customizable based on your requirements. And let's get started. So we can create defects on 2D inspection images, 3D CAD models, and also based on the part names itself. Benefits of using images is that we have the location, which allows us to build a heat map in the reporting. We will show that a bit later. So let's enter some defects. In this case, I'll create a defect on the left fender. Let's say there is an issue of thin paint and it's 3 to 5 millimeters. Then let's say that I found a scratch here and I want to take a picture of the scratch. If data collect is running on a device that has a webcam, we can actually use the webcam to create pictures. So here is an example of a webcam looking at a scratch on a car. I'll click once on the picture to link or to save one picture from the webcam to data collect. I'll close the pop-up. Then if I want to, as an operator, if I want to add a markup on the image, I can, to make the scratch that was found more visible in reporting, and then I can save my scratch. All the data is stored in the database right away, so from this point on the scratch and the images, the picture, are already available in reporting. Then let's go to a CAD model. Let's take a knuckle, and as you can see, we can rotate the CAD model, we can zoom in and out. This way the operator only has one picture to load and they can do the complete inspection. To save some time on the operator, we can create bookmarks to go to predefined views of the, in this case, of the knuckle. And let's say I found an issue there in that hole. The issue was a grind mark, and in this case I have configured Inspect to ask a question, to ask the operator to measure the length. So let's say it was 4.5 millimeters, and I'll save that and save it. So besides creating defects on images and CAD models, we have the option to create it on part names, as I've mentioned. Part names can be categorized either alphabetically or based on categories, so battery, engine. And let's say for the engine, I found an issue with the fuel line, and it's fuel line number 4, and there was the issue that it was loose, and I can save the defect. So that is defect entry. Then let's take a look at the checklist functionality. So here we have the option to show multiple choice, numeric and text questions to the operator. Multiple choice can be anything you want to configure, yes, no, true, false, or asking for a specific number this way. If the operator answers the question with the wrong answer, we can set up validation, configuring the expected answer, and anything else would be wrong. In this case, I know that the expected answer is a desert type air filter. If I pick standard, it will show a warning message to the operator. Here we can instruct the operator to do something. This is completely configurable. And if I save the question, I know that based on the configuration, I know that it creates a defect as well. And based on wrong answers, we can create defects automatically to ensure that any issues found while doing the checklist is being resolved before in this case, the car goes to a customer. An example of a numeric question is here where I ask for a torque reading. So let's say I entered a value of 500, which is completely impossible for this torque. It will say that the value must be between 0 and 30. So the reasonable limit has been set to between 0 and 30. Inside that reasonable limit, there will be a specification limit set. So if I say 25, then it will say that the torque specification is 12 to 25. Since I've already over torqued it, I'll just have to save it, and somebody will have to fix the issue later on. Then we have the option to enter a text value. Here I'm asking for the serial number of the engine that is used in this car. Let's say that I have engine number 68018, and I can save that answer, and it will create a relationship actually in the background between that serial number of the engine and this car. So in reporting later on, I can go from the engine to the car just by clicking on the other serial number, because Inspect knows there is a relation between the engine and the car. With the checklist, we can also attach pictures, just like with the defect entry. An operator, if desired, could type in a comment that would be stored in the database for the answer of that question. And that's on a very high level, the checklist functionality. So if we now take a quick look at the overview, this is where I can see the status of all the defects that are found. I can see that I have created 4 defects while I was doing the visual inspection. I have the air filter of the wrong type that's based on the wrong answer of the question that I showed earlier, and I have the hinge that is crushed because I have over tightened it. So what I can do with the air filter is I can say I've done a remove and reinstall, or remove and install new, it depends how it's configured. And if I do a normal repair process, which takes a little bit more time but allows the operator to add more detail, I can say, in this case, I've done a touch up on the fender. I can pick the responsible area cell that would help in root cause analysis, and I can say it took me 25 minutes. And here again, I can use the webcam to take a picture of the issue found, maybe a picture before and after, and that will be then stored in reporting for the serial number so that it can be shown to a customer if required. If there are multiple defects of the same type, an operator could pick multiple defects, and the repairs that are common are shown here, and the operator could say, well, for these 2 issues I didn't find a problem, and it will close out a defect. Then the last option that we have is to confirm or reject a repair. So you can see here in the status icon that when a defect is created and nothing has been done, the status icon is 1/4 filled red, meaning it's a defect, no repair action has been taken. 3/4 filled green means that the defect has been repaired, and as a super user, as a team leader, I have the rights to confirm repairs, reject repairs, or even remove repairs. And let's say that this one I'll confirm. It was done according to specification, the correct air filter is installed, and the defect status goes to the fully green circle, means that it's repaired and the repair has been confirmed by somebody that has the rights to do that. Then the last piece of functionality I like to show is the travel ticket functionality. This can be useful when you have, for example, inspect in the inspection area but not yet deployed in the repair area. Then what we can do is we can print a ticket. In this case I'm printing it to a PDF file since I don't have an actual printer. In your case it could be printed to a printer or to PDF, and the repair person could open the PDF, for example, based on the serial number. In my example, I'm storing the PDF on the network somewhere, so let's move this over here. I will open the PDF, and here I can see the defects that I have created on the fender, the quarter panel, and on the knuckle, and I can see the status of all the defects with the traceability data that we have. So for any action done by the operator, we always have all the traceability data. So we know when it was done, where it was done, what was done, and by who it was done.